Welcome back. In this video, we'll look at different shapes of uh, input tensors for convolution. And in TensorFlow, we have different options available. The first one is 1D, then we have a 2D, and then we have a 3D. In case of 1D, we can think of this as a row of pixels. So let's say this is a row of pixels and let's say this contains just three pixels. We have one pixel, the second pixel, and the third pixel, and each of these pixels have a value of 1. And so when we look at the dimensions of this tensor, we essentially have just the width, and so we can denote that by a w. And this width is we have 3 pixels, so we say that the width is 3. In addition to this, so let's say if this were a red channel, if this was an image, we can think of this as a red channel, and therefore we can write a name here, that's the red. Additionally, we would have other colors which would be green, so that's the RGB. We have the green color, and at the same time we'll have the blue color, which would be the for the blue channel. With this, then now what we have are channels, and the channels that we have one channel here, second channel here, and third channel. So when we look at the dimensions of this particular tensor, we see that this is going to be we can denote channels by the letter C, and we see that there are 3 channels. So that's the shape we have so far. Likewise, in case of 2D, we would have a sort of a square, and here we'll create a tensor which has let's say 2 rows and 3 columns. And so we have the height associated with this tensor, and we can denote that by the letter H. We have the width, which is going to be the 3 pixels, and so we have that denoted by W. Additionally, we would have the 3 channels, which is the green and the blue color channel. So that's the green channel, and each of these channels would have the same number of pixels, 2 by 3. That's the green color, and then we would also have the blue color, which is let's draw that here, and let's say that's our blue channel with the letter blue, with the letter B here. And uh, finally, then when we look at the dimensions, we have the H that stands for height, W that stands for width, and C that stands for channel. So again, we have these 3 channels. So far the difference between 1D and 2D is that we have the additional H in here. Now moving on to the next 3D case, what we have is we can imagine this as a video clip, because here we can start out with the same sort of dimensions of 2 by 3, like so. So we have sorry, this has become 3. Let me redraw that. So let's put just a single line there, and now we have 2 by 3. So we have 2 that is the height, 3 that is the width. So we have the height, width, and again we would have the channels. So let's draw these channels. We have the green channel right here, and then we have the blue channel. So if we look at and we draw the blue channel, that could be something like this, and we are assuming that the shapes of each of these channels are the same. So this can be denoted by the letter C for channels. Now in addition to this, in case of 3D, we also have something called as a depth. And depth, we can think of this as frames along a timeline in a video clip. So I'm going to draw some of these. So let's say if we draw another square here and another square here. So these could be the two additional frames in the depth, along the depth, and we can add, and each of these frames that we have, they also have the same number of channels that we have been seeing. So they have the RGB channels, and again they are the same shape as for the other channels that we had. So this would again be or 2 by 3, this would again be 2 by 3. So that's how this is set up, and we can put the numbers for these dimensions. We have height, that is 2, width, that is 3, and channels is 3. Again, depth wise we have, so if we were to look at the depth, we are saying that maybe that's the direction in which the depth is there, and or maybe the other way. And so for depth we are using the letter D. Let's see if I can move these up. So if I can somehow select them and move. Oh, it does work. Okay, that's fantastic. So what we are going to do is we will move these up like so, and now we can, sorry about that, we can then draw that depth that we are talking about, and let's say that's the depth, and this is the height, and that's the width we have. So with this then we if we put numbers in these dimensions, we have 3 for the depth, then we have height is 2, 3 is the width, and the number of channels per frame or per image we have 3. Next, another dimension that we have to add to this particular tensor, so as to be uh, so so as to make it as an input to conv1D or conv2D or conv3D, and that is called as batch. So imagine that we have a batch of images, and each of these images, they are similar to what we have above. So let's see if we can copy these. I'm going to try and copy this. Oh, let's just copy this and see if we can paste it here. Oh, it does work. Okay. So let's say we have 1, 2, and we have another 3 such images in that. So total 4 images in this batch. And then we can look at this particular set of images, copy, undo. Let's copy these images. So I'm going to say copy, paste them here. But for some reason, it won't let me copy those. So let's try something. Here, let's complete this first. We then need to, original dimensions that we have had for this tensor was WC, width and channels. Now we have to add the batch. So we could say B for batch, but in the docs, this is referred to as the letter N. And so we'll use the same names, and here we'll specify N, that denotes the number of image tensors in this case per batch. So our final dimensions then for conv1D would be 4 comma we have 3, that is the width, and 3 channels. So that's going to be the input for 1D. Now moving on to the 2D, let's see if we can copy this now. Select, copy, and then paste. Okay, it doesn't want to work. Last try. Paste. Okay, it doesn't work. So I'll simply draw these here. Let me check if there is clear selection somewhere. Don't see it. No, it's okay. Never mind. We'll just go ahead and draw these out. We have this particular image, Then we have another image, and then we have another image here. Likewise, we'll have an image here, and then we have the two images right there. Another set we have right here, and finally we have another set that is right here. And in each of these we have all the three channels. So we'll quickly draw the green channel for each of these images or red boxes that we have drawn, and after that we would go ahead and draw the blue channel, which would be right after this one. And so here comes the blue channel. So the reason for creating this visualization is that it sort of gives some uh, uh, imagine it gives us some room to imagine how the tensors may look like. This is what we have. And if we now look at the batch for the 2D, that would consist of all of these four. And so again we add the letter N in front of H, W, and C. And here we have four images. Height is 2, 3 is the width, and there are 3 channels. So that's going to be the shape of the input tensor to conv2D in TensorFlow. Now here we again would go ahead and add the N, and we can see that we have four sort of we could think of this as video clips per batch, and then uh, each video clip, let's say, has 3 frames, and each frame has a height of 2 and width of 3, and then it has 3 channels. So that those are the dimensions. So points to remember are that in case of conv1D, although this is one dimensional, our input tensor has dimensions that are 1, 2, and 3. So we have an input of 3D. 3D is the input, and in case of 2D, conv2D, the input is 4-dimensional, and in case of conv3D, the input is 5-dimensional. If we now look at the docs here for conv1D, we can see that the data format is NWC, and that's what we were talking about. N stands for the batch shape, so batch. Then we have the width and the channels. So that's the width is W, channels is C. Likewise, for the conv2D case, we have the NHWC. We are introducing the height here, and that's exactly what we see here, where it says batch, height, width, and channels. Finally, in case of the 3D, we have yet another addition next to the height, which is the depth. So we have a a data format that is NDHWC. That stands for batch, depth, height, width, and the channels. So this was sort of a brief overview to visualize how the tensors look like. So when we so hopefully this will help in imagining if the inputs are in correct shape. And now let's get into the notebook here. I had some code written. I'm going to delete this, and we're going to type out this again. So the first thing we'll do is we will create a few tensors, simple ones, and then we'll try to build on them to more complex 3D tensors. So the first one we'll create is x is equal to tf.constant, and here we are creating a tensor that has 3 values. And if we now look at the shape of this tensor, if it's a print x dot shape, we should see that it simply prints out 3 as the shape for this particular tensor. Now if we wanted to add a shape to this reshape this tensor to 3 by 1, here's what we will have to do is we can add square brackets around the 1, and that would change its shape to 3 by 1. Let's look at the output. So that's the 3 by 1 tensor. And if you if you want to see why that is the case, that's because we now have 3 rows, 1, 2, and 3, and 1 column. So that's 3 stands for number of rows, 1 stands for the number of columns. Had we added the square bracket in front of the ones rather than encompassing individual ones, for example, if we added the square bracket like this, then the shape of the tensor that we have is 1 by 3. Now if you run x, this is the shape we get. It's a simple 1 by 3. So we have one row and we have these 3 values in these 3 columns. Next, what we'll do is we'll continue with this particular tensor because that's what we are interested in, the shape 3 by 1, because that's what we were looked at earlier, where we had the batch, W, and then the channels. So we need to add channels to this, and to add, right now we have a shape of 3 by 1. So this tells that there is one channel here, and that's fine for now. If we wanted to add more channels, we could add values inside of it. So we could say 1, 2, 3, and now what we have is a tensor. Let's say if this were a single row of pixels, here it has now 3 channels. So that's why we have a 3 here. And if we now take this particular tensor, and if we wanted to put this in a batch, what we would do is we could put this in a batch and then put a comma and then copy all of this and add a couple more of these. So let's say we add 4 of these. So what we now have is a batch of 4 tensors, each of which has a width of 1. So each has a width of 3 pixels and 3 channels. Now when we run this, that's the final tensor we have, and this could then be input to the conv1d. So 4 comma 3, so that's the batch n, that's the n, this is the w, and that's the c. If we wanted to pull just the values of ones from this tensor, here's how we would do it. And let's say if we want to get values of 1 just from this very first tensor, we would put a number 0 there, and then we have how many width wise, how many pixels do we need. Let's say we need all the pixels, so there are 3 there. And then the channel, we are interested in the very first channel, so we say channel 0, and so this will give us this, and to this we could type numpy, so we see just the array, and that's the 1 1 1. If and to check if that's the array, we could put a value of 10, run those two, and we see that there is 10 right here. Next, what we can do is we can get all the values, and so if we put a colon there, we'll get all the values. So that's the first, second, third, and fourth tensor that we had created in the batch. So this is what we have for conv1d. Let's try and create a few more tensors, and I will now move on to creating something in 2-dimensional space. So for conv2d, these would be the shapes that we need to know. We can create a tensor x that is equal to tf dot constant, and here if we wanted to create a 2D tensor, this is how we would do it. We can have 1 comma 1 comma 1, that's the first row, and then the second row, let's say it also has the values of 1. And if we now print the shape of x, we should see that it's a 2 by 3 tensor as we see here. Now, why don't we put this on in a new cell so we do not get confused with the other values that are getting printed out. So that's the 2 by 3 we have. What we can do next is, to this same tensor we can add channels. So if it's a RGB image, we would have 3 channels. And so let's start out with first channel. So if you wanted to add a channel, here's the dimension we can add. This is the way we could do that. And so now the shape of this tensor is 2 by 3. So that's 2 by 3 as we saw. And then we have one channel there. If we add values to this channel, we can increase, we can add 3 channels. So let's say the second channel has the values 2 and the third channel has the values 3. So we could write that in this way. So we have 2 and 3 values added there, and likewise same here. So now if you look at the shape of our tensor, it's in 3D, but then the values, the the third dimension is the channel. If you look at just one channel, it still is a two-dimensional a tensor of 2 by 3. Next, what we can do is we can add information about the batch. So if we were to put thing in a this entire thing in a batch, what we would need is a square bracket around this. So that's our one image. Okay, and what we can do next is copy paste these couple of times, and just to simulate that uh, these are parts of the same batch. So we have, let's say, 4 images now. So we have 4 images in the batch. Each image has 3 channels denoted here, and each channel is of the shape 2 by 3, where 2 is the height and 3 is the width. If we now wanted to pull the values from the very first image and the very first channel, here's how we would do it. We would say x square bracket, and the very first image would be, let's say, at index 0. Then we need all the rows, so that's the height, all the columns, that's the width, and the very first channel, so let's say that's the 0th channel, and that should give us a value of all the ones in there. That's the ones. And just to be sure that those are the same one that we are talking about, so what we can do is just add a 0 in front of it, so we know that we are pulling just the values of 10 from the very first tensor that we have, and that's exactly what we get here. So that would be a shape suitable for the convolution 2D that we can do in TensorFlow. Now next, let's look at the 3D case. In 3D, we again start out with creating a tensor constant, and here what we have is the same. We start out creating the same 1 by 1 by 1, and then we have 1 by 1 by 1. So that's our 2 by 3 tensor that we talked about earlier. And in addition, we can add dimension here, which is going to be representative of the channels that are there in that particular uh, image. And here we again can introduce the values for each of those channels. Let's say 2 and 3, and likewise for the last one we have the values of 2 and 2 comma 3. And what I'm going to do is simply take this, copy this, and paste it right here. And finally we will print x dot shape, and we'll see how we can build this now. So what we have is we have a 2 by 3 image, right? And each of those we have a 2 by 3 image with 3 channels, and there is information of 1. So that's 1 for the let's say that's going to be the depth, and if we want to add values, if we wanted to add more number of such images to our batch, then this is how we would do it. We could move this particular square bracket there, and we could add corresponding square bracket here, and all of this we can put in another set of square brackets like so, and this now would be so that's there, and this is now inside like so. So we have this one, and we can have another one here. So let's say we have a movie clip that consists of 4 different frames. So we have 4 frames in the movie clip that should reflect in the depth part of it, and then we have just right now we just have one movie clip, and that is this one in this batch that is by the outer square brackets. Let's run this and see if we are doing it right. So we do see that we have a depth of 4, and then we have each channel that is of size 2 by 3, and we have 3 channels. Now if we have more, if we want to add more such let's say movie clips or video clips to our batch, we could do that by by adding them here. And so now what we essentially have are 4 clips. Why not create 5 just to have a different number there? So what we did just now is we added 5 clips right here, and so now when we run this, we should see 5. That is for the number of tensors in the batch. Sorry, number of in this case we are talking about tensor that is that has also has a depth, and then along the depth we have 4 different uh, let's say frames. Each frame has 3 channels, and each channel has the shape 2 by 3. So that's how the input would be for a convolution 3D in TensorFlow. So looking at this, uh, it looks very complicated, but if you follow through the steps that we looked at in this video, I'm sure you'll get an idea as to how to build these. And once you know how you can build them, it becomes easier to relate these numbers to the shape of matrices and sort of imagine how those numbers are laid out or how those matrices are laid out. Now let's take a look at a real RGB image and its tensors or the channel values in the channels. For that, we'll first import library, import matplotlib.pyplot as plt, and then we'll create a variable img to load the image. Keras dot utils dot load underscore image load underscore img. Then we have content sunflower dot png, and so if we print the type of image, we see that it's a image file, and so what we'll have to do is convert this to a tensor. So if we can first look at the image, plt.imshow and img plt.axis, and set the values to off and say plt.show. So this way we should be able to see the image, and that's the image we have. Now to convert this to a tensor, we can say image2 is equal to tf.convert to tensor img, and if we now look at print type of img2, we should see that it's a tensor. Now it's a tensor. and we can look at the shape of this tensor into shape, and here we see that this is 212 by 218 pixels, so that's the 212 is the height, 218 is the width, and 3 is the number of channels. If we try to look at this image, the tensor, these are the values we have, and while we cannot see all the values, so what we are going to do is we are going to pull just a few values. Let's say if this starts 0 is here and we have 200 here, around right about here we may have the value for 100, and maybe here there will be 50. So let's try to get some values from 50 onwards. So 50 up to, let's say, 55, just a few values, and then same thing for the uh, width. Along this, let's say we get values from 0 to 50 for this one. So let's go from 0 to 50, and the channel, for now we'll use all the channels and put this information into another variable img3, and then look at img3. So these are the values we get. Still, these are many values. So what we can do is limit the values to, this is 0 to 50. I think that's the reason why we have so many values. Let's go from 50 to 55 instead. So we have much less values. So we have modest 5 values, 1 2 3 4 5, and 5 values there right here. So what we can do now is this consists of all the 5 channels, right? If we print it, if we try to plot it, we can simply copy the code we had above. To save time, we'll simply paste that here and run this to see what image. So this is the image that we have, and to look in further directions, what we can try and do is we'll put this as just a 0, and maybe put this as 0, and see what type of image we get. So what I'm trying to see is where we are looking at. So that's the part of the image we are looking at, and if we start at, let's say, 40 along the height, then that's the image we are looking at. Again, if we narrow down this even further, if we want to look at this part, we could start at 10, and so we remove the sky part, most of it, and then we could stay right up to here 20, and that's the part we have. Okay, and why don't we make this as 45 to 55, so that's 10, and then we have 10 right here. So these are we have the sky, and we have some colors from the petals. So with this particular information, we can let's put this here as well. So we have the img3 that looks like this. That's what we have. What we can do next is we can pull just the values for red channel, and for that what we can do is here, as we know the shape of this tensor. So if you look at the img3 dot shape, we see that it's a 3-dimensional tensor, height, width, and number of channels. We say we want all the rows, we need all the columns, but only from channel 0. And so this would be the channel. This is our channel. You see, img3, if we pull the uh, entire array here, then we see that this is 182. That's that 182. Then we have the next 182 here, and then we have the 187, which is right here. Then we have the 190 right here, and so on, and the last value would be 193, which is right here. So that's how this particular array is set up. If you look at this doesn't look like 10 by 10, right? But when we try to pull this information, we see that this 10 by 10 is laid out in 3 channels. When it's laid out in 3 channels, that's the way this is written. and we can also plot this particular channel. So let's create a cell above this, and you say PLT. Why don't we copy and just simply reuse the code that we had? Instead of img2, we'll just say img3, and this is what we have. That's everything. And now we'll add the slicing, and once we add the slicing, we should see that we just see this particular just the red channel, and we can specify the CMap color map as gray, the CMap as gray, and that'll give us the gray shade of this one. If we say that, oh well, why don't we try to plot the image 2 with the gray color? That's the red channel for that image. If you look at the green channel, this would be the green channel. This would be the green channel, and if you try to plot the red channel, sorry, the blue channel, then this would be the blue channel that we have. So different channels, we get different values inside of the pixels, and that's why we see different shades of gray. All right, so at least from this particular exercise, you now have an idea as to how we were able to extract the values from for each of these channels from the image and plot them. We'll go one step further, and what we'll do is we'll copy this, and what I'm going to do is create a red channel. Red is equal to this, and we are going to pull all the values. So let's say all the values from the red channel. So we can do that and say this is the red channel. Then we will do the same thing with other two channels, the blue and the green. So for green, we can specify the index of 1. Then for blue, we can specify the index of 2. And so that's what we have. If we now try to put them together, we'll have to put them along the depth. So we'll have to stack them correctly so that we see the image that we want to see for the sunflower. Let's put this, and if we now try to plot just the red array or the red tensor, that's what we see. Okay, so to get a color image, we'll have to put these arrays appropriately so that we can see the color image once again. And to do that, here's what we can do. We already have the RG, red, blue, and green tensors created separately. We see how they look like when we plot them separately. What we can then do is, let's say, combined image, and we can simply call this RGB is equal to, use tf.stack, and we'll specify the tensors that we would like to combine, red, blue, and green, and then we'll specify the axis. So we want this to be stacked along one behind each other. So let's say that's the third axis we have. And now we can look at the shape, print rgb.shape. We should see that it's again back to the original shape that we had started with, and we can finally go ahead and plot this plt.imshow rgb, and we can set the axis to off so we don't see the axis, and finally plt.show, and run this. And here is the final reconstituted image we have from the 3 channels that we started out with. I hope this was helpful in giving you an idea as to what goes on in the background when we look at an image and how to visualize the inputs for the convolution neural network in TensorFlow. Next, what we can take a look at is a video clip and see how the matrices would look like in a video clip. In the very beginning, we talked about the depth and a frame, and we will now see an example of that. And for that, what I did was I recorded this short video and without any audio, and I've uploaded that here in the name of test_video. That's the video will open in TensorFlow and see how the frames look like and how the values in the tensors look like. I've gone ahead and done a few steps ahead of time. If you go to this particular link, I'll put the description, put this link in the description. What you want to do is you want to copy the functions, two functions from there. The first function is format frames, and the second is frames from video file. And you want to import CV2 library. So once you have that, you can run those cells, and after that we can load the image. So for loading the video file. So here is the test video MP4, and I'm loading the frames, 10 frames from this one. And as we can see, when we run this particular cell, we get an array of shape 10. So there are 10 sets of 10 frames. So these would be the frames that we referred to as depth in the beginning, and then each frame is an image that is 224 by 224 pixels with 3 channels, R, G, and B. If we let's say if we remove this, I'm not sure if it will take all the frames, or if it yeah, it does require us to put the number of frames. So if we put the frames as 20, if that change anything, we do get the 20 frames here. So for now we'll just keep things simple, and we'll have just let's keep just 4 frames, and random is not defined. Okay, so let's keep the minimum 10 frames uh, so that this particular function gives us the desired output. Now the sample video that we have is this. From this sample video, what we'll do is we'll pull the very first frame, and for that we'll put a index 0 for the first frame, and then for these we need all the height, all the pixels along the height and width, and all the channels. So therefore we have put a colon there. Now when we run this, what we get in the output is a numpy array. This numpy array we can then we can plot it, and that's the very first frame that we have from this particular video. We can do one thing. We can copy this and put this right here, and we can look through other frames that are in this video. We can look at the second frame with at index 1, and then we can look at the 10th frame that will be at index 9, and so that's a blank. And we look at the frame at index 8, it's blank too. How about index 5? Do we see anything? And that's blank as well. Wonder why. If you look at index, well, that is blank as well. And so looks like most of the frames in this video are blank except for the first one. We just have 0 and 1, so we just have 2 frames that are of use to us. Or why don't we just use the first frame? Now let's say this is the frame we are interested in. What we'll do is we'll look at what the values are in this particular frame. So if we type frame, we see that that's the matrix, and these values of 0 probably refer to this dark region, dark band, black color on the top and at the bottom of the image. In this particular, we can look at the size or shape of this. We should see that it's 224 by 224, and we can again crop this. We can slice this. So let's say if we want to look at just the face part, we are looking at pixels from around 70 to 125 in height. So we'll put that here, 70 to 125. Then for width, we are looking at pixels at around 90 to, let's say, 140, 90 colon 140. And for channels, let's keep all channels there for now. And I'm going to copy this, paste it right below, and copy this and put that up here. So that's the frame we are looking at, and this should crop the image, and that's the face we can see. And in this, if you look at just the channel 0, that gives us the red channel, the RGB. So we can set the CMAP to gray, and here is the channel red. That's next is the green channel, and finally we have the blue channel right here. So this is how we were able to now visualize a video right down to the channels. And this same sample video, so let's bring the sample video again here, sample underscore video dot shape. That's the sample video we have, and we can try to stack this video by using tf.stack, and in list we can give the sample video, and let's say we want we could copy this and paste it here several times. Let's say 1 2 3 4, maybe one more 5 times. Rather than doing that, we could do it the other way, and that is just simply put a *5, and we'll put this along the axis 0, and the output will put this in another variable, and we'll call this a video batch, and we'll look at the shape of video underscore batch dot shape, and you'll see that it should be the shape that we would anticipate, which is 5 10 224 224 and 3. So 5 would be referring to, so here's what we have. 5 is the number of videos in a batch, and each batch five videos in a batch, and each video has 10 frames. That's the depth part, and then each frame has 3 channels, that's the 3, and each channel has 224 pixels along the height and 224 pixels along the width. So that's how this particular we can imagine how the tensor for a video batch would look like. And again, if we wanted to access the red channel from the very first frame of the very first video in the batch, here's how we would do it. We have the video batch, and to access the very first video, we put a 0. So that's the video at index 0. Then to access the very first frame, we choose index 0 again. Then to choose all the height and all the width, that's the colon, and to select the red channel, we select that particular, we again use index 0, and this we can look at the output, or we could plot it by saying plt.plot plt.imshow, and that's the array inside of that, and below that we can say plt.show, and we should see just the red channel. So that's the red channel. We can set the CMAP again to gray to see it in grayscale. That's the video. I hope in this particular video you got a fairly good intuition about understanding and trying to imagine how how the inputs for con 1D, 2D, and 3D would look like. Um, and just to recap, then for one-dimensional convolution 1D, the input has N, W, and C. So it's a three-dimensional input. So three-dimensional tensor as an input. For conv 2D, the input has N for batch, and then you have the height H, W, which is the width, and C. So that is four-dimensional. And finally, when we look at the video, you'll have input that would be five-dimensional as shown here, which is the batch, you have the depth, and then the height, width, and the number of channels. So thank you. I hope again you enjoyed this video. Please stay tuned for future videos in this series. If you have any comments or suggestions, please do let me know. Next, I think what we'll try to do in following videos is look at the actual implementation of Conv 1D, 2D, 3D, and so on. Thank you.